This is lesson 21, so we're going to start off by reviewing the derivative at a specific point. So if you remember, if you're looking for the derivative at a specific point, okay, so if you're looking for, in this case, for the secant, the slope of the secant, if you bring those 2 points together, then you would find this to be the derivative, all right? The derivative at a point C is equal to the limit as x approaches C of f of x minus f of c over x minus c. So please remember that, because we're going to have to compare it to what we're about to do on this lesson. All right, so for the formal definition of a derivative, all right, notice that what we're going to do first, and it's actually what it tells us right here, we're going to find the coordinates of Q. So the coordinates of Q, hang on just a second. The coordinates of Q would be, well, in this case, the x coordinate would be x, and if you add this piece right here, notice that this distance from here to here would be x, so from here to here would be x, and if we add delta x, then the distance will be x plus delta x, and then the y coordinate would be f of x plus delta x. Okay, so that would be it for that. So now, to find the slope of the secant line between P and Q, so again, we're trying to find the slope between those 2 points, right? So if you remember, the secant line touches 2 points on the curve. So if we're trying to find the slope of the secant, all right, remember that we're going to use the slope formula. So we would say that, you know, y sub 2 is minus y sub 1 over x sub 2 is minus x sub 1, all right? So in this case, where we have f of x plus delta x, that would be y sub 2's, minus f of x over, notice that the x coordinate of Q, all right, the x coordinate of Q is x plus delta x. So I would have x plus delta x, which all of this is the x coordinate of Q, minus the x coordinate of P, all right, which would be just x. So notice that right here, this x's would cancel out, and you end up with this. Now, if I let, what happens to the equation as delta x goes to 0? So if delta x goes to 0, right, so if this distance right here goes to 0, then those 2 points would be right on top of one another, all right? And when you put those 2 points right on top of one another, then you would have the slope of the tangent line like you did previously, like on lesson 18. All right, so notice that this and this are the same formula, but except for this one has the limit as delta x goes to 0, right? And this will give you the derivative. This will give you the derivative right here at any point, all right, on x. That will give you the equation to find the derivative. Sorry, to find the slope at any point that you like, and I'll give you an example in a minute. Okay, so now let's go ahead and go to the back. So you got to pay attention to this though, because a lot of students miss this because they don't know what they're looking for. Remember, if I ask you for the slope or the derivative, all right, I can ask you in 3 different ways. Notice the notation f prime of x, which you should be familiar with that now. But I could also ask you, well, what is dy dx? Well, dy dx is the derivative of y with respect to x. It's the same thing here. And then finally, if in your AP exam you would see f prime of x with this definition, this also means the derivative. All right, this is the formal definition of a derivative. All right, so what we're going to do now is we're going to go ahead and do one example where we're going to find the derivative of f of x using the formal definition. Okay, so notice that you can see the formula up here, which is a good thing. So we have f prime of x is equal to the limit as delta x goes to 0 of, now notice that this is f of x. So f of x, I'm going to write it up here, f of x plus delta x would imply that I would need to plug x plus delta x into each one of these x's right here. Cadence. Okay, so now we would have x plus delta x squared plus 2x plus delta x. All right, so now, the limit as f of x plus delta x is this. So we have x plus delta x squared plus 2x plus delta x minus, all right, minus f of x. Now f of x is x squared plus 2x. So we have minus x squared plus 2x all over delta x. Okay, so notice that in this case I can just write delta x because that's part of the formula. All right. So now notice that if I try to take the limit as it is, I would have a 0 in the denominator, so I need to at least expand this, and hopefully something will cancel this delta x. All right, so to expand it, and you do have to write f prime of x is equal to the limit as delta x goes to 0 every single time you make another line of text here. All right, so notice that if I square this, I'm actually going to FOIL it, right? And if I FOIL it, I want to have x squared plus x times delta x times 2, which would be 2x delta x plus delta x squared. Okay? Now, that was the FOILing of this. Now I'm going to distribute that too, so I have plus 2x plus 2 delta x. Now notice the delta x itself is just a variable, right? So right here, this is not going to be delta square x squared. It's just going to be delta x squared. All right. As we move on with this, we have minus x squared minus 2x over delta x. Now at this point, some of the steps should cancel out here. We have x squares cancel. The 2x's cancel. Okay, so now what we have left here, delta x goes to 0 of 2x delta x plus delta x squared plus 2 delta x over delta x. Notice on the top, what do we have in common, all right? What's my common factor? And then hopefully you can tell that you have a delta x that you can factor out. All right, so I have this right here. So I have delta x. If I factor that out, I would have this left. Okay. Now notice that finally my delta x's are going to cancel, and that's a good thing that the bottom canceled out, because that was the main problem that I had. And then now I am free to plug in 0 for delta x, and if I do, then I would get that the f prime of x is equal to 2x plus 0 plus 2, right? Which is just 2x plus 2. Okay, so again, this equation right here, this is the equation of the derivative of f of x, is right here. Okay, by the way, notice that you need to write the limit as delta x goes to 0 all the way until you take the limit, which I did here, and then I no longer write it after that. And yes, you do have to write that because that's what they expect out of the AP exam, and I will count it wrong if you don't. Okay, so now that I've taken the limit, I don't have to write the limit as delta x goes to 0, and I have this. So just to make sure you understand, so this is the derivative function. So, for example, if I'm looking for the slope of the tangent line of this function right here, say at x is equal to 2, right? So all I would have to do is plug in a 2 into this function and then figure out what that is. So that gives me a slope of 6. Okay, so let's say that I'm looking for the slope of f of x at 3. Well, I can plug in that 3. So this is actually much faster to do. All right, you can find the slopes a whole lot faster if you have to, if you take the derivative and find the derivative equation, and then from there on you can find out any slope on the f of x function. All right, all you have to do is plug in that x value that you're looking for. Okay, this is probably by far the most tedious homework you're probably going to do, because you're going to have to do the formal definition of a derivative. But if you have any questions, please let me know.